My talk will focus on how our application interact with the database, and I will introduce a couple of ideas and a couple of concepts on how to improve the way how your application logic is structured, and I will also introduce you to Agile Data, the data access framework, which I'm currently working on, and it's not a new thing. It's actually based on the model class from a commercial framework which was released in 2011, and right now I'm just refactoring it and creating a separate library, and I want to release it under MIT license with full documentation, and so that all of you can use. It's a framework for business logic, so it looks at how you organize it, but will also take over interaction with the database. It introduced a couple of really interesting concepts, and I'll talk about them in my presentation, about dataset and actions. And finally, it works with SQL and NoSQL vendors, and it's really extensible. Okay, so let's take a step back and talk about how your application works with database. And one of the most established and old way is while you're outputting HTML is to send a couple of queries to your database to fetch the necessary result. And many developers still do that, execute those direct queries. Let's look at pros and cons. It's very straightforward. You have good control, you have good performance, but unfortunately your logic is messed up. Presentation, databases, all in one big chunk. Very difficult to separate and unit test any of that, and you need to watch out for SQL injections yourself. Your application depends on a specific SQL structure, and if anything is to change inside the SQL code, half of your application might need to be reviewed, because potentially it might create queries, so you'll have to retest that. You also will end up duplicating quite a lot of code, especially queries, because you have separate pages which kind of do the similar thing, and they might be sharing your code. So if you change query code in one place, you need to go through all of your code, making sure it's changed everywhere. A couple of developers in some of the applications have adopted a use of persistence library. Essentially that's a library which helps you interact with the database and introduce a little bit of order in there. And there are two types. The first is query builder, and it's just helps you abstract the query. You still build a query, but you build it through creating an object. You are in a full control, the logic is better, you are safer now, and the performance is still great. But you don't escape the logic issue, it's still the query is in your code. You don't have any unit tests. Again, you have quite a few unnecessary code, and your application still depends on SQL vendor and the structure. Your other option is object relational mapper. And if with a query builder you were abstracting the query, here you abstract the record inside the database. Pros are the code is finally much easier to read. You also have better logic. Most of ORM, they operate with models. They will allow you to place your business logic inside the model, which is great, and you can finally separate it from the presentation. And you can finally do some unit tests, which is awesome. But most of object relational mappers, they have performance problems, and I will look into them later. And your application still depends on SQL vendor and the structure, because the way how you build your app is you reverse engineer your database into objects. Like, Cake PHP uses the term baking models, and your business logic is not always the same as your database. One simple reason: the database is not object-oriented. Your business logic, it can be, but a lot of us who used ORMs had to sacrifice that. The model, the domain model, is the concept used by things like Hibernate, in Java, in PHP there is doctrine, so there's a really industry standard concept, and in this concept we separate the business model from the way how it stores itself in a database. And this is, I think, the most appropriate way to write code. So you have presentation code, the next layer is a business model, which they call domain, and then we have a persistence as well. And in this we are still abstracting, but we abstracting business entities, not the records. We work with business entities. Objects represent business entities. How they're stored in a database, this could be a big mystery, but it's abstracted, we don't care about that. The code is easy to read, logic is much better, safer, you can do unit tests, the performance can be optimized, because you can write custom queries inside business logic, and an application, they no longer depend on a single SQL structure or vendor, it now can be conditional. So but there are downsides, and first of all you have to learn a lot. There's a lot of concepts to learn, and now you also have to write a lot of code. And this is exactly the issue when I think the approach is correct, but implementation is not. And Agile Data, it introduces a new way how to implement this three-layer approach in your application, but do it in a better way. So a couple of key values or key goals of Agile Data and design goals mostly is to be simple. I would want Agile Data to be so simple that the new developers could just start using it, and it will be very easy to explain, and you'll see it later. It needs to teach correct approach from the very beginning. For developers, it needs to place them in control. I love PHP, you guys love PHP, and I believe the framework shouldn't look at Java or Ruby. Instead, it should be very PHP-like. Agile Data works anywhere. You can use it in WordPress, you can use it in any frameworks. It has very little dependencies, and you just attach it, and you build your business logic with Agile Data. And then finally, it covers all the possible usage cases. So at no point in time you would say, oh well, you can't do it with Agile Data, you'll have to do a raw query. That's just wrong. The framework is designed to be able to support any possible database interaction, necessary database. So the easiest code to write with Agile Data is this one. And I'll go to you line by line. And the first one, we're establishing the connection. You're familiar with this concept. User represents a model, and in this case, this is a anonymous model because it just creates from the generic model. And the only thing we set is a table, and then we can iterate through this model, and we get the name of users. That's the field from database. That's probably the easiest way, but it actually is bad because we haven't defined any business logic. You can see there's the code, the amount of code you write is it's very, very small. It's just as much if you would have written your own query. So there is no reason why you should write queries, because you can do this. And now let's talk about how we do it correctly. Model user is going to be our business model, representing a user in our system. Now we link it with a table user, saying, okay, the user will sit in that table, and we define 3 fields, and our definition of the user is complete. Now next, if you're looking at the code from the previous page and how it's improved, we no longer create anonymous user, but instead we use our new model. So we operate with model. Now we don't have, like in presentation logic, we no longer have to we don't have to specify the table anymore, but it's gone. It's inside the model itself. So we don't have to specify. The other thing I must point out is that the model itself, it's not linked to MySQL. So it's presentation logic which connects the database with the model. And that's really key. You will see why. Okay. Next, let's extend our business logic. Right? Adding a new model. And in here, I'm suggesting you extend your business models and make other business models on top of that. Okay, it's like, we have users, we have client. On top of that, we could add another model for VIP client, or the client who has expired. These could be all separate models. We can define all of them as we want. And we add a condition for this model. So this is similar to how scopes operate in Laravel, but it's kind of better. And again, back to presentation code, if we need to work with clients and not users now, all we have to change is the name of the class. Right? The same logic is, the logic is the same. And as the next step, let's add a couple of methods inside our business logic domain. So in here we create a method for sending out verification email. And now that we have this logic in there, we need to use it in presentation, and you see the example in there, in which we're using a real mailer. For the unit test code, we're using a mock mailer, and probably we're also using a mock database, but that's what I said, right? So the model itself doesn't rely on a specific database. It just describes the business logic, and can be connected from the outside. So that's really key. The separation of business logic is the key. You have presentation code which focus on presentation, business logic focus on business logic, and you have framework which focuses on persistence or generating queries. This, guys, is called single purpose rule, and that's one of the key requirements when it comes to enterprise software. This is how you write a good quality software. The unit test can be written easily, and the code is easy to maintain, support, and refactor. Okay, let me take a step back. Let's look at the ORM and some of the performance issues. So what ORM does, it maps our database. The reason I'm bringing ORM now is because we'll be comparing the patterns with ORM. Agile Data is not ORM, it's slightly different. There are some similarities, you'll see them side by side. So with ORM, you have issues with querying, and there are memory issues, and I'm going to go through all of these points one by one and highlight them. And probably the most popular problem is called N+1. And if you have 20 clients and each of them is having a bunch of orders, you might end up with a simple logic like that. You might end up executing 21 query inside your database. The first one is to fetch the clients, and then 20 new queries to fetch orders for each individual client. If you look at the code, it's properly written. There's nothing wrong with this code. This is how ORM wants you to write the code. Yes, and suddenly it's a huge performance issue. So there are also memory problems in here. Again, it depends on, I'm not focusing on any individual ORM implementation, I'm more looking at them in general. So when we're fetching the clients, sometimes you would get all the clients, or there is you get a lot of unnecessary information, and then when you update things, so like you're only interested in amount, but the order, the variable order, will also have other properties in there, even though you don't need it and you don't intend to do anything with it. It is still there. That's a memory problem, and that's a problem with bandwidth as well. Lazy loading. This is like a patch on ORMs, where let's say instead of loading all the data, we're just going to load IDs. But if you access them, we're going to load them, the rest of them. And your code remains the same. But the lazy loading, it tries to solve things. And then in order to write a good code, you need to be aware of whether or not you're going to be using lazy loading or eager loading. And it's just wrong. The other issue is ID stuffing, and that's when you have multiple IDs, right? So when you do lazy loading, and you want the framework tries to optimize the loading of orders and preload them for you, which by the way might not be something you actually will want. It will create a query with a lot of parameters, and now as long as I have a couple of million records in the database, the whole thing just explodes. No, it doesn't work anymore. You have to solve it otherwise. And the number of queries increases as well. So in this example, I'm going over all the order and changing a property. Again, I'm using the PHP code, which seems correct, but what happens at the end, because the ORM thinks about the database as something really dumb, you end up with a lot of individual queries to change individual values. And how is it solved? Well, more caching, right? Cache things. But there is also another way to solve that, and it's not to use ORM at all. And that's what a lot of people do. In Laravel, the ORM itself extends Query Builder. So every model is like based on query logic. The query logic is under each model. And what's the problem here? Unit tests is no longer easy to use. You lose all the benefits of ORM if you do that. There's no abstraction of query logic anymore, because query logic is, you use it. You might use this in your presentation logic, and it's not separating anymore. There's no abstraction of database vendor, because this clearly says we're going to be using SQL, right? And the fields, as you can see, we are now working with fields, so the fields are not abstracted either. How to solve these problems? And one of the most important things is to understand our databases are not just dump key value storages. Some of them are, but most of them are not. So let's move some logic to the database. Let's educate developer where exactly query will happen. Also, let's not keep multiple records in memory, and let's use a simple and transparent logic for the code. And finally, let's give developer access to abstract developer features such as sum over multiple records, because this is used very frequently. And this is what Agile Data does. It was necessary to create Agile Data because ORM cannot be fixed. And this is the indication. So in ORM, an active record, you have one memory object corresponding to the record in your table, right? And in order to represent multiple objects in table, you have to use multiple records in memory. And Agile Data, it creates one object for the whole set of rows. Okay, one record, single record in memory, can represent multiple records in a table. Now, the way how it defines is not by listing all the IDs, but by listing conditions. In this type, the condition is that in this scenario, the condition is that the type equals to client. This is an example of ORM code in the query builder I brought from the previous slides. So and this is how Agile Data solves the issue. Because it works with the data sets, you can traverse not a single record, but you can traverse a data set. So we take all the clients and we take all their orders, and that's our new data set. We call it client orders. And once we have this data set, we can call a sum operation, which gives us back an action executed to be executed inside our database, but it's not. Until this point, we haven't done a single query. And when I call get1, the single query will be executed in a database, and it will just give me the number. So no sending of IDs or other information back and forth. We just carefully prepare the query and send it. So this is like a query builder, but it uses the intelligence of the models. It has guaranteed performance, and there's no sacrifice. Doesn't sacrifice anything. Let's look how we can iterate with that. So again, I'm fetching orders of all the models. I have just got rid of a single for each, right? So I have only one query in this scenario. But we iterating through the records, we're changing the value, and we're saving them. Now, some ORMs, they will ask you to explicitly save the data. Laravel does it. Others will transparently save data as you change your properties. In case of Agile Data, we always indicate where something is going to happen to the database. We teach our developers that the save will be happening in here. And developer sees that save is inside the for each loop. That means multiple saves will be executed. And we give developer a choice. You can go this, you can do that, but there are alternatives. Save itself is an action. So instead of executing save right away, we can group them and execute them together. Okay, that's another option. We educate developer to be aware of this execute, and we give him choice. But that's not the only choice. We can also move logic to the database. We did it when we were calculating the sum. We can also do it when we're changing things. And now we take, again, the same set client orders, and we're executing action across all of the data set. And within this action, we say we will set this field to this value. What's important to point out here is that the way how the field and the value is interpreted here is up to our domain logic. We're not exposing ourselves to the database fields. Reminder set, it might not be a field in a database after all. Maybe it's some abstract concept, whatever. But we don't care at this point. When we writing the logic like that, when we're using it in the presentation layer or in the domain layer, we don't want anything related to persistence in there. We are abstracting all of that. And so at the bottom line, we can safely perform actions in dataset, and it gives us better performance. So this, on the SQL Server, if you use SQL Server, it will execute one query. If you use Mongo, it will execute two queries. And if you use some dump storage, like storing in an array or a file, it will execute more operations, but it will execute as little as possible for the vendor of your choice. And the most importantly, you don't have to change your code when you switch from one vendor to another. We have also addressed memory consumption. And on the second line over here, you see that I'm using the method called setActualFields, and it essentially instructs my object, so which object is reflecting dataset. it instructs on when I'm going to be iterating through the rows. I'm only interested in amount. I don't care about other fields. And initially, maybe I won't have this actual field at all, but it's really easy to add. You can go through all your code, and you see, okay, I'm only going to be using amount in here. Let's add set actual fields. It optimizes. It tells which fields to query. And inside the for each loop, we're not creating new object for every row, because remember, one object represents the dataset. We're iterating over the dataset. There is an internal pointer, and as the results come in, and we never prefetch results, we always stream results from the database. So as the results come in, we still operate with the same object. The only thing that changes is the property data inside our order. And if you look at that, it will contain only two values. One of them is ID and second is amount. Okay, so very minimalistic, very simple, very transparent use of data. The user is aware, or developer is aware of loading, and yeah, so that's it. So key points from this presentation. Single record mapping does introduce performance problems. And instead, we introduce dataset and action mapping, right? So it's not record mapping, it's dataset and action mapping. Sounds a bit complicated, but that's a really powerful concept. The implementation is lightweight. We don't introduce invisible caches or any other magic. It needs to be as transparent as possible. And we solve problems fundamentally. We show and educate developers how to solve these problems. And they know about performance. So when they write applications, they understand the performance. And that's Agile Data, and it's coming to all of you in 2016 under MIT license. So I hope you're looking forward to it.